Now we have a activity here where we're asked to find the lines of symmetry. Now, lines of symmetry are where you can put one line, and if you fold it down that line, you will have exactly the same on both sides. Now, here in example 1, you've got one line already drawn for you. Here's one line of symmetry. Now, if this was a square, it doesn't look like a square. I think it's slightly longer. I think it's slightly higher than it is wide. So let's assume that this is the height and this is the width. And therefore, if that's the case, we've only got one line of symmetry. So there's only one line of symmetry in this first diagram. Now this second diagram, if this was an equilateral triangle, we could put a line of symmetry here. We could have a line of symmetry down through here. We could put a line of symmetry straight through here. And when you fold it on those three lines of symmetry, so here we have 1, 2, there are 3 lines of symmetry. So 3 lines of symmetry for the triangle. Now here we have an oval. Now the oval we could have is one line of symmetry straight through across here and one line of symmetry straight down the center here. So this has 2 lines of symmetry. So I'm just going to put 2 here, 3 here, 1 here. Working our way through this. Ooh. Go back to number 1. It's not only 1, is it? We've forgotten straight through here. You probably saw that and think, oh, Mr. Laurie's asleep. And yes, I was. So here we could fold it halfway. And that would be 2 lines of symmetry for this rectangle. Because then we've got this rectangle that's the same thing. But if it was a square, let's say this was a side and this was a side, then we would also have a line of symmetry down that diagonal. We would have a line of symmetry down that diagonal. So that's what you would get if it was a square. So let's go back and say this has 4 lines of symmetry, and let's call this a square. It must be a square to have 4 lines of symmetry. Let's call this an equilateral triangle. So it's equilateral triangle, so all 3 sides are the same. So if that was an equilateral triangle, we would have 3 lines of symmetry. This is an oval or an ellipse. We'll call it an ellipse. There's 2 lines of symmetry. Here we have a rectangle, and a rectangle has only 2 lines of symmetry. So that's down the center here, through the center here. So this one has 2 lines of symmetry. A circle's an interesting one. A circle, you can have an infinite number of lines of symmetry because you could just put that diameter absolutely through the diameter, the axis of symmetry, or a line of symmetry. As long as it passes through the center point, you could have an infinite number of lines of symmetry. Alright, 1, 2, 3, 4, 5, 6. This is a regular hexagon, so if all sides are the same, I'll call this a regular hexagon. And if it's regular hexagon, you can have, you've got 3 lines of symmetry if you put it through the points. That's 3. However, there is another 3 if you go straight through the middle of each side. So if you were to go right through the middle of each side, you have another line of symmetry. If you fold it in those 6 folds, they will always fold perfectly. So this one has 6 lines of symmetry. Now let's call this a square with curved edges, and again we could put a line of symmetry straight down through that diagonal. Missed the diagonal a bit. And through that diagonal, and then straight down through that diagonal. Now we could fold it through that side. We could fold it through that side, and we have 1, 2, 3, 4 lines of symmetry. If this is a diamond, we could fold it here and here. If it's a square on its side, we could also fold it here and here. So if that was a diamond with equal sides, we've got 4. Now this is like an arch. We've got one fold here, only one line of symmetry there. We cannot fold it anywhere else. Here we could have one line of symmetry straight through the point, and that's only one line of symmetry. This shape, we could fold it halfway. That's only one line of symmetry. Here we could fold it in this half or this half, and we have 2 lines of symmetry. So I hope this has helped you with finding lines of symmetry. Just remember, you must be able to fold it in half on that axis, and it's the same on both sides. So until we talk again, stay happy.